This video is on section 6.6 notes, solving trigonometric equations. So we've gone through all the trig identities and how to use those identities to evaluate problems and how to use those identities in proofs. And now we're transitioning a little bit and we're actually going to go through and solve trig equations that have like specific answers. So I wrote some definitions here to kind of help you determine maybe the difference. There's a little bit of nuance between the two types of equations we've looked at throughout this unit. So we have mathematical equations in trig that are identities and then just regular equations. The identities are ones where no matter what angle you plug in, they're always true. So lots of different angles can be plugged in that makes them true. A trig equation has specific solutions, maybe one solution, maybe several solutions, and if it does have several solutions, they would have a specific relationship. They would be coterminal to each other. And where a trig identity, any angle could be used. In a trig equation, there would be some angles that just would not work. All right, so here we're going to go through and we're just going to start solving these, and then I'll kind of explain some specific things to solving trig equations. So if we have cos x equals 1 and I want to solve for the angle x, then I need to undo the cos. So I'm going to do cos inverse of each side of the equation. And so I get the angle x is cos inverse of 1. And if I look at the unit circle and look to see where the x coordinate is 1, I can see that the angle that is there is 0. And so I'm going to say x, that angle is 0. So I know that if I had cos of 0 in radians or degrees, I would get 1 as an answer. But then I also have all of the answers that are coterminal with 0. So for instance, just making sure I'm in radians. So if I had cos of 2 pi, that would also equal 1. Cos of 4 pi would also equal 1. 6 pi, 8 pi, 10 pi, 12 pi, and so forth. And so we're going to say that all of the solutions are 0 plus 2 pi k. This would give us all those coterminal solutions. And technically, since 0 is, 0, you don't really have to write it. You could just say x equals 2 pi k. So this is how we do all the solutions on negative infinity, infinity, is by writing all of the coterminal solutions as well. Okay, let's try the next problem. So this one says cos x equals 0, so I know that the angle is going to be cos inverse of 0. And if I look at the unit circle, I can see that cos is the x-coordinate is 0 at pi halves. And if you recall from earlier on in the unit, we talked about when you have an inverse function for cos inverse, you would look at quadrants 1 and 2. But if you had sine inverse or tan inverse, you would look at quadrants 1 and 4. And this is going to be a little bit different from that, and I'm going to do my best to kind of give you a contextual reason for why. So do not write this down, but I'm just going to kind of talk through this because we've kind of done this before in math. So if you were doing these problems, you would be like, oh, the square root of 4 is 2, the square root of 9 is 3, the square root of 25 is 5, the square root of 81 is 9. And you would just have a single answer for all of those. But if you were doing this problem, x squared equals 36, you would say, well, I'm just going to square root each side. And I know that on the right side, since I'm the one who introduced the square root into the problem, I need to say plus or minus 6. So that if the square root is already written on the paper, if they have a positive square root 4, then they want the positive version. If they have positive square root 9, they want 3. If they wanted the negative version of the number, then they would have said, hey, give me negative square root 100, and then they would have wanted negative 10. But over here, if I have an equation and I'm solving the equation, then I need to say, if I take the square root, there's two possible solutions. It's positive 6 and negative 6 that could have been squared to get that 36. And that's the same thing when we work with trig functions. So with trig functions, when we talk about inverses, if we are the one taking the inverse, then we are no longer limited to two quadrants on the unit circle. We are now going to consider every single place where cos equaled 0. We're going to consider every single quadrant on the unit circle. So we have not just pi halves, but we also have 3 pi halves. We have 2 places. So I'm going to say x is pi halves plus 2 pi k. Those are all the answers that are coterminal with pi halves. And I'm going to say x equals 3 pi halves plus 2 pi k. And these two answers can kind of be pushed together to be a little bit more concise, because if you notice, pi halves and 3 pi halves are 1 pi away from each other. So that means that cos is going to be 0, or the x-coordinate is going to be 0 every pi. So pi halves would be 0, 3 pi halves would be 0, 5 pi halves would be 0, 7 pi halves would be 0, 9 pi halves, and so forth. As we go around, we don't have to add a full circle to find the next answer that would give us 0. We just have to add half a circle, or we have to add pi to find the next one. So I'm going to cross these out, and I'm going to write one answer that works for both of them. I'm going to say pi halves plus pi k. And that's going to get all of the answers for me, including the coterminal answers. And it's just these two kind of pushed together. Okay, for this last one, I'm going to say x is cos inverse of negative 1/2. I'm going to go ahead and look on the unit circle to see where I have an x-coordinate of negative 1/2, and that's up here at 2 pi thirds and down here at 4 pi thirds. Notice these are not 1 pi apart, so I actually do have to write these two answers separately. So x is 2 pi thirds plus every coterminal angle, and x equals 4 pi thirds plus every coterminal angle. So any of those, 4 pi thirds plus 2 pi k, any of those would give me the same output if I was to plug them into that equation. All right, so here's a summary of the different answers we can get. So it just says if the output of the equation cos is 0, then you have this, pi halves plus pi k. If cos is positive 1, then it's 0 plus 2 pi k. If you have negative 1, then it's pi plus 2 pi k. And then if it's one of these other solutions, if it's anything else other than 0 or 1 or negative 1, then you kind of have these more interesting solutions where you have your first answer on the unit circle. So this S is kind of from that inverse function, so that's from quadrant 1 or 2, and then you have 2 pi minus that. And for us, we won't really use this. We're just going to look at the unit circle and get our two answers. But I still want you to highlight this, because if you come down here, sometimes we're going to have problems like this where we are using our calculators. And if we're using our calculator because we have a decimal, then this formula is going to become really, really important for us. Okay, so I'm going to go ahead and find the solutions for this equation when we have a decimal. So I'm going to say angle x is cos inverse of negative 0.832. And they said we're going to define S as cos inverse of A. So I'm going to figure out what this is. I'm going to call it S. So that's right, I'm in radians. So I'm going to do cos inverse of negative 0.832. Okay, 2.553 is my first answer. So my first answer is S plus 2 pi k. So I got S was approximately 2.553. So my first answer is X equals 2.553 plus 2 pi k. That's my first answer. My second answer is 2 pi minus S plus 2 pi k. So I'm going to do 2 pi minus, and then I'm going to go up here, highlight S, and press enter, so it copy-pastes it, 2 pi minus S, 3.729. The 29 is followed by a 6, so I'm going to write 730. 3.730 plus 2 pi k. And so here are my two answers. Just like if I was doing this problem, and I had two answers I found on the unit circle, I can have two answers that I found using decimals, but I can use this formula to do it. Okay, let's try sine next. So same sort of idea here. It says to solve this sine equation, we have sine of x equals -1/2, and so I know that angle x is sine inverse of -1/2, and so I'm going to look at the unit circle and see where the y coordinate is -1/2, and that's down here at 7 pi 6 and over here at 11 pi 6. And so I have x equals 7 pi over 6 plus 2 pi k, and 11 pi 6 plus 2 pi k. Over here, sine x equals √2/2, and so angle x is sine inverse of √2/2. And so I'm going to look on my unit circle for where the y coordinate is √2/2, and that's right up here at pi fourths and at 3 pi fourths. So I have x equals pi fourths plus 2 pi k, x equals 3 pi fourths plus 2 pi k. Right? So we have similar rules for sine. If sine is 1 or -1, you either have 3 pi halves plus 2 pi k or pi halves plus 2 pi k. If sine is 0, then you have 0 plus pi k, or you could say pi plus pi k, or you could say 2 pi plus pi k. It doesn't really matter which one you use. But for the sake of my math lab, I think you have to put 0 plus pi k. And then we have these ones. I just lost my highlighter. We have these other two rules, which are going to be beneficial anytime we have a number that's not on the unit circle. So we're going to use this little rule down here when we do this next problem because we have a decimal. So here I'm going to say angle x is sine inverse of -0.4. And so I'm going to go ahead and figure out what S is. So the S is sine inverse of the angle. I'll highlight that as well. There we go. S is sine inverse of the angle. -0.4. And I get -0.412. So S is approximately -0.412. Okay, now they give us two scenarios. They say if S is positive, if S is greater than 0, then you can use this to find your two answers. If S is negative, if it's less than 0, then you should find your two answers doing this. Okay, so I'm going to do S plus 2 pi. So what they're having me do first is they're having me find a coterminal angle, so I'm not writing down a negative value on my paper. And that is just kind of good practice because typically they want the answers to be between 0 and 2 pi, and a negative answer is not. And so I'm going to take this answer and I'm going to add 2 pi. So this is my S plus 2 pi, 5.872. 5.872, now plus 2 pi k. And then my second answer is going to be pi minus S. So I'm going to do pi minus, and then I'm going to go back up here. This is my s value. Pi minus s, 3.553. Plus 2 pi k. And pay attention to this when you plug these into my math lab and see if they make you write one of them first or second, because they might give you instructions so you write these answers in a specific order. But it's as simple as that. I went ahead and I just followed the directions here for s is greater than 0 or less than 0, and I could use those formulas. Okay, and then last we're going to go ahead and do the same thing and just look at how to solve a tangent equation. So we know tangent is going to be a little bit more complicated because we're not going to see a value of -1 on the unit circle for tangent. We're going to look for a y-coordinate divided by an x-coordinate that is -1. So here for tangent, y divided by x is -1 is right up here. The y and the x are the same number but different signs, so that's going to be -1. And then over here, that's going to be -1. And one thing we'll always notice about tangent is that the answers for tangent are always across from each other. They are always a full pi apart. So we have 3 pi fourths, and then over here at 7 pi fourths. And so I would say x equals 3 pi fourths plus 2 pi k. X equals 7 pi fourths plus 2 pi k. But I don't really need to write two answers here. I can condense them down and write it as one answer. I'm going to say x equals 3 pi fourths plus pi k. And I'll only ever need to write one answer for tangent. Okay, so let's do this one over here. The angle is tan inverse of √3/3. And so I'm going to look on the unit circle and see where I have a y divided by x that simplifies to be √3/3. And it's right here. 1 divided by √3 becomes this. So it's pi sixths and 7 pi sixths, and they typically, between the two of them, want you to write the one that's smaller. So I'm going to say x equals pi over 6 plus pi k. If you were in a testing situation and you weren't putting this answer on my math lab, but you were just doing it for me, I'd be fine with either. Pi 6 plus pi k would get full credit, 7 pi 6 plus pi k would get full credit. I just don't know if my math lab would mark you down or not. Okay, and then down here we have the shortcuts for tan. It says if s is tan inverse of the angle, then any solution can be found using these formulas. Okay, so we'll go ahead and do it for this one. This is one that would not be on the unit circle. So the angle is tan inverse of -2. So if I type tan inverse of -2, I get -1.107. So s is -1.107. And it says we have two scenarios: if s is greater than or equal to 0, if s is less than 0, and this s was less than 0, so I'm going to go ahead and do this version. So again, they're going to ask me to add pi because they want me to find one of the answers for tan that is not negative. So I'm going to add pi because tan answers repeat every pi, and I'm going to get myself a positive answer before I start writing down all of the possible solutions I have. So I've got 2.034 plus pi k. Okay, So that's how you solve just kind of the regular equations. Now we're going to look at some equations that have multiple angles. And what I mean by multiple angles is instead of saying sine of x equals something, it says sine of 2x or sine of 2 alpha in this case. Or maybe it could say sine of 3x or sine of 5x. And so it means that we're going to be changing a little bit about the problem, and I'll show you as we do this one how it changes. So I'm going to go ahead and start off the problem exactly the same way. I'm going to say that 2 alpha is sine inverse of negative root 2 over 2. So I'm going to look at my unit circle and I'm going to see where I have a y coordinate of negative root 2 over 2. So it's right here at 5 pi fourths and over here at 7 pi fourths. And so I'm going to write out both of those answers. So instead of saying x equals, I'm going to say 2 alpha equals 5 pi fourths plus 2 pi k. And 2 alpha equals the other one, 7 pi fourths plus 2 pi k. Okay, and then I don't want to know what 2 alpha equals, I want to know what alpha equals. So I'm going to divide by 2, divide by 2. Divide by 2, divide by 2. So alpha is 5 pi fourths divided by 2. You can think of this as 5 pi fourths divided by 2 over 1, and you can do keep it, change it, flip it. This would be 5 pi over 8. So fourths cut in half gives you eighths. Plus 2 divided by 2 is pi, plus pi k. And then the other answer would be 7 pi eighths plus pi k. So this is our solution on the interval from negative infinity to positive infinity. And then if we want to find the answers from 0 to 2 pi, then we can actually use these as kind of like formulas to give us the answers. So I would say we have 5 pi eighths, and then plus 1 pi would be plus 8 eighths. So 5 eighths plus 8 eighths would be 13 eighths. Plus another 8 would be 21 eighths, and that's too big. Because 0 to 2 pi in terms of eighths would really be 0 to 16 pi eighths. That's what 2 pi is if you have it as a fraction with the same denominator. So 5 pi eighths, 13 pi eighths. This one would start with 7. And then if I add 8 eighths, I get 15 pi eighths. So depending on what interval they gave you, you could have different answers. So this is if they said all solutions negative infinity to infinity. Here if they said 0 to 2 pi, these are the specific solutions. Okay, let's try another one. So this one says tangent of 3 alpha. So I'm going to start by saying 3 alpha is tan inverse of negative root 3. And so I'm going to look on my unit circle to see where the y coordinate divided by the x coordinate simplifies to negative root 3. And it's right here, 2 pi thirds, and also down here at 5 pi thirds. And for tangent, I only have to write one version. So I'm going to say 3 alpha is 2 pi thirds plus pi k. And then I'm going to solve for alpha. I'm going to divide by 3, divide by 3. And so alpha is 2 pi thirds over 3 over 1. You can do keep it, change it, flip it. Or you can think of thirds divided by 3, which would be ninths, plus pi thirds k. So if we think about all of our possible solutions, this is what they would be. If I'm going to go through and find them, then I would say this is 2 pi ninths plus 3 pi ninths, if I wanted to do it by hand. So 2 pi ninths plus 3 pi ninths. So I would have 2 5 pi ninths plus another 3 is 8 pi ninths, plus another 3 is 11 pi ninths, and I'm going to go up until 18 pi ninths is 2. So 14 pi ninths and 17 pi ninths. Okay, perfect. So that's how you deal with it if you have a double angle or a triple angle or something like that. So if you have a double angle, I'm going to show you this. So if we had just a regular angle, just alpha, then you'd have 2 answers. If you have 2 times alpha, then you have 4 answers. If you have 3 times alpha, you have 6 answers. So you can kind of see how the number in front of the angle can either increase the number of answers you have, or if you had like 1/2 alpha, then you would have less answers. So just something to keep in mind. Okay, and then I wanted to go over a couple of these problems as well, just problems where you would have to factor to find the answers, because we haven't talked about factoring yet, and that's something that you can run into. So if you have a problem like 2 sine x minus 3 sine x plus 1 and you need to factor it, a lot of times I like to think of my factoring in terms of just regular variables and kind of factor off to the side, and then I like to put it back into the trig notation. So I would think of this as like 2x squared minus 3x plus 1. And for those of you who have taken a class of mine before, you know that when I have a number in the front, I like to do the slide divide method. Any method you do works if you like the box method, or if you just do guess and check or whatever. However you factor this is fine. But if you're doing the slide divide method, you would say 2 slide over to 1 and multiply. So 2 times 1 is 2. So we'd be looking for 2 numbers that multiply to 2 and add to -3. And the numbers that multiply to 2 but add to -3 would be -2 and -1. So then our factors to start with are x minus 2, x minus 1. And so we did the slide step, that was 2 times 1. Next is the divide step. So we take the number that we slid, the 2, and we divide by 2. And we reduce these if we can. So 2 over 2 reduces, it reduces to 1. 1 over 2 does not reduce, and so I would leave it as a 1 over 2. So then once we do the divide, then we do bottoms up. So we take the bottom of the fraction and move it up to the front. So 2x minus 1, and then these are your factors. So now that I have factored it in terms of like, you know, regular variables that are easier for me to think of, I'm going to take the x and I'm going to replace it with sine x. So I have sine x minus 1 and 2 times sine x minus 1 equals 0. And then just like I would do with factoring over here, I would say like, oh, my answers are x equals 1, x equals 1/2. You can do the same thing over here. So sine x equals 1, sine x equals 1/2. And then now I can go ahead and grab my unit circle. So my angle is sine inverse of 1, and my angle is sine inverse of 1/2. And the instructions said to just find the answers on the unit circle. So sine inverse of 1 is pi halves. Sine inverse of 1/2 is pi 6 and 5 pi 6. And so these are my 3 answers for this factoring problem. Okay, let me try another one. So I would write down that this one is 6x squared plus x minus 1. And if I did the slide divide method, I would do 6 times -1 is -6. So I'd be multiplying to -6 and adding to a +1. And the two numbers that would do that are positive 3 and negative 2. So I would have x plus 3, x minus 2. And so since the number that I slid over was the 6, then when I divide, I'm going to divide by 6. And both of these can reduce, and so I'm going to reduce both of them. I have x plus 1/2 and x minus 1/3. And then when I bottoms up, I'm going to bottoms up both of them because they're still fractions. So 2x plus 1, 3x minus 1. And now I can go back and put them in terms of cos. So it would be 2 cos x plus 1, 3 cos x minus 1. And for this one, it would be x equals negative 1/2, x equals positive 1/3. So cos x equals negative 1/2, cos x equals positive 1/3. So this one is on the unit circle. This one needs my calculator. So cos inverse of negative 1/2 2 pi thirds and 4 pi thirds. And I didn't put the interval in the problem. We're going to do this one for negative infinity, infinity. Okay, so cos inverse of negative 1/2 is 2 pi thirds plus 2 pi k, and 4 pi thirds plus 2 pi k, okay? And then for the other one, I'm going to get my notes out. That's sine. Let me get my cos notes. Okay. I'm going to use this because I'm going to have to use my calculator. So I'm going to do cos inverse of 1/3. Cos inverse of 1/3. This is defined my s. There's my s value. And so it says for the first one, just do s plus 2 pi k. 1.231. Okay, and then for the second answer, do 2 pi minus s. .052. All right, last problem. Sine times cos equals 2 sine. So whenever I factor something, I always have to make it equal 0. So I'm going to say sine times cos minus 2 sine. And for this one, you could factor it by thinking of it as like xy minus 2x. You could think of it like that. So if you look at this one, you can see that there's a GCF of x that you would factor out, and then your leftovers would be y minus 2. So if I look at that in terms of this problem, I could see that sine is like my GCF of x, and then cos minus 2 are my leftovers. So I have sine, and my leftovers, cos x minus 2. So, and here if we were solving this, we'd say x equals 0 and y equals 2. So over here, we're going to say sine x equals 0 and cos x equals 2. Okay, sine x equals 0, so I'm going to say x equals sine inverse of 0. So we're looking for where the y coordinate is 0 on the unit circle. and I can see the y-coordinate is at 0 and pi, and then 2 pi. And I have to be careful, and this does not happen very often, but it says on the interval from 0 to 2 pi, and the way that this is written, it's telling you which answers to include and which answers not to include. So it has a parenthesis around 0, which means that in a situation when 0 and 2 pi are both answers, 0 should be excluded, 2 pi should be included, because 2 pi has a bracket, 0 has a parenthesis. So 0 is excluded, 2 pi is included. So pi and 2 pi are answers that are good, 0 is not. It's not a trick question, they're just saying they want answers on the unit circle, but they don't want any coterminal angles. They want you to be just specific and put each individual angle once that has the same terminal side, and they happen to be specific that they want 2 pi, not 0. Okay, this one over here says cos x equals 2. X equals cos inverse of 2, and you might recognize this already, but sine and cos graphs, they only have outputs between -1 and 1. They're never going to have an output of 2. And so this is actually undefined. And anyway, you'd look at this and say, well, that's not on the unit circle. Let me use my calculator. And you'd say cos inverse of 2, and you'd get an error message. Okay, so 2 cannot be plugged into this. This does not give us any answers. The only answers we have for this question are the pi and 2 pi.